In this video, I will give an overview of various TEAL opcodes and a general idea of how they work within the Algorand Virtual Machine, or AVM. I will also show you where to find details on all other TEAL opcodes in both the Algorand developer portal as well as in the Go Algorand GitHub repository. Before I explain about the opcodes, let me briefly explain how the AVM works. The Algorand Virtual Machine works by evaluating opcodes one at a time, and will remove data from or add data to something called the stack. The stack can be thought of as a last in, first out array containing of either byte arrays or unsigned integers. The Algorand Virtual Machine can also read and write to scratch space, which is temporary memory per transaction, although it is possible for a transaction within the same group to read the values of a previous transaction's scratch space. This topic will be covered in more detail in another video. Lastly, the AVM can use global and local state as well as boxes for more persistent storage, and again this topic will be covered in more detail in a future video. There are over 180 opcodes in the AVM at the time of this video, and I won't be able to demonstrate anywhere near all of them. However, it's worth understanding the different types of opcodes you'll come across when using TEAL. Opcodes come in three different forms. Either as standalone opcodes, where they are self-contained and don't use any additional parameters. For example, the following opcodes: error, intc_0, bytec_0, and itxn_submit, don't require any stack or immediate values. Then there are opcodes that require immediate values, which are values following directly after the opcode. For example, pushint, txna, store, and global, which all require additional values after the opcode. Finally, and most commonly, are opcodes which use values taken off the top of the stack. These include plus, equals equals, char256, len, dig, and swap, which all remove one or more values off the top of the stack, manipulate the data, and place a new value or values back on the stack. The observant among you may have noticed dig uses both stack values and immediate values, which is also possible. Another important piece are the pseudo opcodes, which don't exist as opcodes themselves, but represent another commonly used opcode which it's converted to during compilation. For example, int and byte are pseudo opcodes for pushint and pushbyte. Additionally, you can provide an encoding value such as B64, B32, or 0x, which will again be converted for you during compilation. The best way to understand what opcodes exist is by looking through the opcode documentation on the Algorand developer portal. This is constantly up to date with the latest changes and should definitely be bookmarked and the first place to go when working with TEAL. For the more advanced users, I'd recommend following the Go Algorand GitHub repository and looking through the following files in the Data Transaction Logic folder. readme.md gives a thorough explanation about all the details of the AVM. Opcodes.go includes an array titled opspecs, which includes a list of all the available opcodes. And finally, eval.go contains the implementation of all these opcodes if you wish to understand how the AVM works with each opcode.